Okay, so we're going to start with some key facts about electrolysis. So first of all, what is electrolysis? Well, electrolysis is the decomposition or the separation of molten or aqueous ionic compounds using electricity. We are extracting metals that are higher than carbon in the reactivity series, so more reactive than carbon, from their ores. And we are only dealing with molten or aqueous compounds. And this is because in molten or aqueous state, ions in the compound are free to move throughout the structure and carry charge. That means that these compounds will conduct electricity. Now, I'm showing you the simple electrolysis diagram now, and we need to be able to decipher that the positive electrode is called the anode and the negative electrode is called the cathode. And to help you remember this, we have the acronym PANIC: positive anode, negative is cathode. And they might ask you, why are these electrodes made of carbon? Well, there are three reasons. Number one, carbon is inert, it's unreactive. Number two, carbon conducts electricity. And number three, it's relatively cheap. We're now going to look at ions within electrolysis. So in electrolysis, our compound is usually made up of a non-metal as well as a metal. Now, as we know from previous videos, those non-metals will form negative ions and metals are going to form positive ions. Now, you need to be able to understand that negative ions are going to be attracted to the anode because opposites attract, and therefore positive ions are going to be attracted to the cathode. Now, at the anodes, when those negative ions are attracted to the anode, they will lose electrons to become an atom. That is oxidation. Because of oil rig, oxidation is loss, reduction is gain. So vice versa, the positive ions are going to be attracted to the cathode. There they're going to gain electrons back to become an atom. Remember, those positive ions have more protons than they have electrons, so they need to gain more electrons to balance out the charges and therefore become neutral, an atom. So because reduction is gain, that is going to, metals are going to perform reduction. And we use the phrase ions will be discharged at their relative electrodes. So, for example, if we were electrolyzing lead bromide, lead is the metal in this compound, so it's going to produce the positive metal ions, Pb2+, so it'll be attracted to the cathode because opposites attract. Now, Pb2+ has two more protons than it has electrons, so to form that neutral atom, we need to gain two electrons back, so we'd have Pb2+ plus two electrons makes Pb. Because we are gaining electrons and because we are adding those electrons on the left-hand side of the equation, this would be reduction. At the anode, bromine is going to be attracted. Now, because all halogens come in pairs, we have Br minus, but it needs to make Br2. It needs to make bromine. Now, that means we need to balance that equation. So we're going to put a big 2 in front of the Br minus. So we've got 2 Br minus makes Br2. So we're going to add the 2 electrons onto the other side. So we'd have 2 Br minus makes Br2 plus 2 electrons. This is essentially the loss of electrons because this equation could be written as 2 Br minus take 2 electrons makes Br2, and that would be oxidation because it's the loss of electrons. Now, there is a required practical for electrolysis, and we might be asked to electrolyse copper chloride, copper sulfate or sodium chloride. So first we'd half fill a beaker full of the solution. We'd then connect a simple circuit using crocodile clips and wires to connect the electrodes to the power pack. We'd then switch that circuit on and collect the gases at the electrodes. We use ignition tubes filled with solution, inverted and submerged to do this. We're then going to test the gas at each electrode. So remember to test for hydrogen, we're looking for a squeaky pop. For oxygen, a glowing splint will relight in the presence of oxygen, and in the presence of chlorine, damp blue litmus paper bleaches white. Record the substance present at each electrode, then we're going to disconnect the circuit and pour out the solution. We then repeat with different solutions. If they ask you to include safety precautions here, well, copper sulfate is an irritant. That means that if it gets on our skin, we should wash it off and we should wear goggles throughout the experiment. As well, we have live wires in this experiment with the risk of an electric shock. Therefore, we shouldn't touch the wires. And the last one is that we do have the risk that we will spill solution and that will cause slips. So we should wipe up any spilt solution. And I've seen before the question, why does the solution become a lighter blue during electrolysis? Well, it's Cu2+, copper ions, that make the solution blue. So the concentration of Cu2+ ions will actually decrease as copper atoms are formed at the electrodes. And this means that the very substance that is making the solution blue is decreasing, and therefore we're going to get a lighter colour. And then we have a sort of mini case study within electrolysis, and that's electrolyzing molten aluminium oxide. But first, there's a few quick things that we need to know about aluminium oxide itself. So aluminium oxide is actually found within the compound bauxite, which contains not just aluminium oxide, which is written as Al2O3, you need to learn that, but as well iron oxide. It's actually mined in Russia and Jamaica, and it's actually red in colour. Now, we cannot displace aluminium from its compound, aluminium oxide, in a blast furnace, and that's because aluminium is more reactive than carbon, so we're going to use electrolysis instead. Remember that we are electrolyzing aluminium oxide in its molten form. That's why aluminium oxide can conduct electricity, because the ions are free to move. And we're going to add a substance called cryolite, which brings down the melting and boiling point, which means that we need lower temperatures, therefore less energy, therefore it's actually cheaper. The overall equation for the reaction, which I suggest you learn, is that 2Al2O3 makes 4Al plus 3O2. Why do we want aluminium anyway? Well, it's got some useful properties. It has low density, it's a good electrical conductor, it's malleable and ductile, it's non-toxic, and that means that we can use it in planes, pans, cans and telegraph poles. So metals form positive ions, so aluminium is going to form Al3+. It's going to be attracted to the cathode, therefore opposites attract. So we're going to have the half equation at the cathode as Al3+ plus 3 electrons makes aluminium, so Al. And at the anode we have 2O2 minus makes O2 plus 4 electrons. Now this oxygen actually reacts with the anode, it burns with it, making CO2 that degrades the electrode, wearing it away. Now there are 3 disadvantages to the electrolysis of aluminium oxide. Number 1, we have high temperatures, that means we've got high costs involved. Number 2, we've got electricity costs, and number 3, we have the cost of replacing that anode. That means that the electrolysis of aluminium oxide is very, very expensive. The solution to this problem is recycling aluminium. This is much cheaper. And then we have the electrolysis of aqueous solutions, and we have a little case study here of brine, NaCl, and we have uses for the components. So the hydrogen ions involved can be used to make fuel, margarine and ammonia. The chlorine ions can be used in making hydrochloric acid, disinfectant and purifier, bleach. The hydroxide ions can be used in making bleach, paper and removing pollutants from water. Now, in aqueous solutions, determining the products at the electrodes is a little bit more difficult, and this is because aqueous means dissolved in water, so we are introducing H2O, which will separate out into one hydrogen ion and an OH minus, a hydroxide ion. So there's 2 rules that we need to learn. So at the anode, if there is a halogen present, that halogen will be made. So halogen is anything in group 7, for example, chlorine is present in brine, that means that chlorine is going to be made at the anode. If no halogens are present, oxygen will be made, and that oxygen comes from the hydroxide ions. At the cathode, whatever is less reactive out of the metal and hydrogen is made. So if the metal is more reactive than hydrogen, hydrogen is made. If the metal is less reactive than hydrogen, that metal is made. For example, in brine, we have halogen present, that's chlorine, so chlorine is made. Also, hydrogen is less reactive out of sodium and hydrogen, so hydrogen is made, it's discharged. So the overall equation is NaCl makes H2 plus Cl2 plus NaOH, which is the leftovers. The leftovers are essentially squished into a little compound there. And there is an equation you need to learn if no halogens are present, and it is 4OH minus makes 2H2O plus O2 plus 4 electron minus. And so how I like to remember it is 4 people on holiday, OH minus, 2 in the water, H2O, 2 on the beach, so O2, and 4 electron fish. And that's all of C6, so well done if you made it to the end of this video, and see you next time.